On the 23rd of July, 2024, a large hydrothermal eruption occurred in the Biscuit Basin of the Yellowstone National Park. After weeks of thorough investigations, Mike Poland, the scientist in charge, explains the mechanism of this event.
Well, in the time since, we've learned quite a bit about this event and things that might have preceded and followed it. Now, the explosion was not caused by the direct interaction of magma and water, magma causing water to flash to steam. Rather, it was caused by the accumulation of boiling water and steam at shallow levels. All of the rocks that came out from that explosion are glacial debris and sand and siltstone that are sourced at very shallow levels, none of the rhyolite bedrock that's about 175 feet beneath the surface. The seismometers, the cameras, the thermal probes that were put out after the explosion have detected surges that have occurred subsequently. Probably real big outpourings of water from Black Diamond Pool that moved rocks around and put silt deposits on the shores of the pool. Nothing particularly big, and most of them happening at night, so not observed. We also learned from citizen science reports, photographs from prior to the explosion, that there may have been a precursory sort of surge from the pool, probably on the night of July 16th or 17th, based on how rocks moved around between those two time periods. So we're learning quite a bit about this previously underappreciated hazard, the most likely hazard to occur in the Yellowstone region, especially on human timescales. That's the story here from Biscuit Basin. Now let's talk about the seismic activity, ground deformation, and geyser activity that occurred over the past month.
It was another pretty quiet month for earthquakes in the Yellowstone region. The University of Seismograph stations located just 54 events during the month of September. As usual, most of the earthquakes occurred in this band that goes east-west from Hebgen Lake into the north-central part of Yellowstone National Park. The largest earthquake of the month was a magnitude 2.2 that occurred just to the west of West Thumb on September 1st. So background levels of activity in terms of earthquakes. Now looking at ground deformation, this is vertical deformation at a GPS site near Lake Junction. Each one of these blue dots is 1 day of data. Downward trends indicate subsidence, upward trends indicate uplift, and the entire plot spans the last 2 years. Now since 2015, the whole caldera has been going down. It's been subsiding by a rate of about 1 or 2 inches per year, and that's interrupted in the summer months by these brief periods of uplift due to all of the groundwater and snowmelt that's percolating into the ground, causing a seasonal signal. We can see that seasonal signal started here in June, July of 2024, and it is ongoing now. We probably expect that to roll over as we get deeper into the fall. And finally, looking at Steamboat Geyser, the tallest geyser in the world. This is the temperature measured in the geyser's outflow channel. There were a couple of periods where the logger was not working properly, so we don't have any data there. But you can see overall during the month of September, there was a lot of up and down motion, and that's caused by minor activity of the geyser. We see a lot of minor activity before there's typically a major eruption. So it looks like, since we had minor activity the entire month of September, there really ought to be a major just around the corner in October.